The basic unit for measuring capacity in the metric system is the liter. And we can apply all of our prefixes that we talked about earlier to the word liter in order to generate other units for measuring capacity. Now, of all of these units that are possible, the two that are in primary use are the liter and the milliliter. Now, I think it's worthy for us to pause for just a moment and talk about the relationship between a liter, between these measures of capacity and the idea of linear measure. There is a close relationship, and we found it in the last section when we talked about gram. Remember, we said that a mass of 1 gram is nothing more than the mass of 1 cubic centimeter of water. So we have that 1 cubic centimeter, you see, an idea of distance or length associated with the idea of mass. And we have a similar association here with the notions of capacity. And this is kind of unique because we didn't have these when we talked about the customary system. And I'll mention why in just a little bit, but let's talk about that relationship. Suppose we imagine a cube which is 10 centimeters on a side, 10 centimeters long and wide and high. All right, now 10 centimeters is the same length as 1 decimeter. You see, so 1 decimeter, 10 centimeters, same thing. And to give you just another idea of that, it's this. Now here's a meter stick. Let me get it right side up. This 10 is at the point of 10 centimeters. So each one of these little marks is a centimeter. So this is 10 centimeters. And that is 1 decimeter. So what we're talking about here is 1 cubic decimeter, which is 1 liter. So 1 liter is 1 cubic decimeter. And I actually have a model of it here. This is a model of 1 cubic decimeter. And the capacity here, the amount of space in here, if you will, is the amount of space for 1 liter. So that gives us a feeling of this liter idea. Now, I think it's also important for us to realize this, that if we're thinking in terms of decimeters, then 1 by 1 by 1 would be 1 cubic decimeter. Okay, if we're thinking in terms of centimeters, then we have a cube which is 10 centimeters by 10 centimeters by 10 centimeters, which is 10 times 10 times 10, or 1,000 cubic centimeters. So 1 liter is 1,000 cubic centimeters. Now, that's only important because of this. Think about a milliliter. Milliliter. Now the milli part means 1,000th. So a milliliter is 1,000th of a liter, so 1,000th of a liter. But we just said that a liter is either 1 cubic decimeter or 1,000 cubic centimeters. So this liter is 1,000 cubic centimeters, but look at this, 1,000th times 1,000, they would cancel, and we would have 1 cubic centimeter. So a milliliter of capacity is a cubic centimeter. It's a cube which is 1 centimeter on a side. So it would look something like this. Now, this is kind of an important correlation. In fact, in the world of medicine, when shots are given, you often hear nurses say something like, or a doctor say, we want 5 cc's of something. And they're using this cc idea for cubic centimeter. And that's the same as a quantity of milliliters. You see, so 5 cc's would be 5 cubic centimeters. You see, so they are interchangeable, milliliters, cubic centimeters. Let's keep that in mind. All right, let's go through some conversions, and they're going to be similar to the ones that we've had in the last section or two. Convert 824 milliliters into liters. So 824 milliliters to liters. Once again, we could use a chart kind of like this. Remember, this is kiloliter, hectoliter, decaliter, liter, deciliter, centiliter, and milliliter. Now, we're going from milliliters to liters, so we're going from milliliters to liters, and this chart will tell us direction and how many places to move the decimal point. So we're moving the decimal point from milliliters to liters, 1, 2, 3 places to the left. From here, 1, 2, 3 places to the left, and we get this. So 824 thousandths of a liter for 824 milliliters. Now, the other way to think about it is like this. We're going from milliliters to liters. We're going from small units to a larger unit. Larger unit, less of them, divide to get less, divide by the number of milliliters in a liter, that would be 1,000. Divide by 1,000, move the decimal 3 places over, get the same result. All right, in this next one, similar idea. Convert 1.25 liters to milliliters, and we can go through the business up here. Let me erase just a little bit to kind of start over. Very similar notion, though. Let's see. Liters to milliliters. So liters to milliliters, we are sliding to the right 1, 2, 3 places. So this decimal slides to the right 1, 2, 3. We have 1,250 milliliters then in 1.25 liters. And the other way to think about it is liters to milliliters, we're going to little bitty units. There'll be more of them. We multiply to get more. There are 1,000 milliliters in 1 liter, so we're multiplying by 1,000, multiply by 1,000, move the decimal 3 over, and we get the same result. Now, this is going to seem like a trick question. 46 milliliters is equal to how many cubic centimeters? How do we figure that out? Well, a little while ago we talked about this relationship between a cube that is a centimeter on every side, a cubic centimeter, and the capacity of a milliliter. You see, it's exactly the same. So the conversion is actually trivial. This is really 46 cubic centimeters. And if we're going the other way, same idea, 25 cubic centimeters is 25 milliliters. Now, this, though, has a little challenge to it. 325 cubic centimeters is equal to how many liters? Well, now, wait a second. We know that there's a nice correlation between cubic centimeters and milliliters, but there's no nice correlation between these two. However, here's what we do. We think. Well, let's see. How about a thought bubble here? We think that this is nothing more than milliliters. You see, we think about this as milliliters. So we have 325 milliliters is how many liters? Oh, okay. Milliliters to liters going into a larger unit, fewer of them, divide to get fewer. There are 1,000 milliliters in a liter. We're dividing by 1,000. Divide this by 1,000, slides the decimal 3 to the left. And we're done. That's all there is to it. Let's go in the other direction. We have 1.05 liters into cubic centimeters. Once again, we think about this. I love these thought bubbles. We think about this as though it were a milliliter. So think about changing liters into milliliters, and we're really changing into cubic centimeters because these are kind of like interchangeable parts. All right, so liters into milliliters. We're going to a smaller unit. There'll be more of them. We multiply to get more. The number of milliliters in a liter, 1,000. We're multiplying by 1,000. Slides this decimal point 3 over to the right. 1, 2, 3. So we have 1,050 milliliters, or 1,050 cubic centimeters for the conversion. Now here's that combined conversion situation. 4 liters and 32 milliliters is what in terms of liters only? Well, we think of this as 4 liters plus 32 milliliters, and now we're going to convert this into so many liters and then bring them together for our answer up here. All right, so we're changing milliliters into liters. We're going to a larger unit, fewer of them, divide by 1,000 because there are 1,000 milliliters in 1 liter. Dividing by 1,000 shoves this decimal 3 to the left. Boom, boom, boom. We need a 0 as a placeholder, so we have 0.032. Then adding these two, it's 4.032 liters for our answer. Here's a word problem. A lab assistant is in charge of ordering acid for 3 chemistry classes of 30 students each. Each student requires 80 milliliters of acid. The assistant must order by the whole liter. Wow. Sounds complicated when we first read it. We need to figure out the total number of milliliters. Now notice, the amount that each student requires is given in milliliters, and yet the assistant is going to order in whole liters. So we want to know how many liters, and yet we're given information in terms of milliliters. That's one challenge. Another challenge is that we have 30 students in every class, and there are 3 classes. So we have 3 classes with 30 students in every class. How many total students would there be? Well, we can figure that out by multiplication. Now, we can multiply everything at one time, or we can take our time with this, and I recommend that we take our time. So if we're talking about 3 classes with 30 students per class, then we're talking about 3 times 30, or 90 total students. All right. Now, every one of these students needs 80 milliliters of acid, so we're going to have 90 times 80 milliliters. Now, it's right here in the problem where we bump into that choice, whether we want to work the problem or find out how much capacity we need in terms of milliliters, or whether we want to change the milliliters into liters and then do the multiplication. I think it's just as easy, perhaps a little easier maybe, to change into liters first. And let's do that. Let's change. Let's see. We have 80 milliliters is how many liters? That's what we're going to do. All right, 80 milliliters. Milliliters to liters. We're going into a larger unit. Fewer of them, divide to get fewer, divide by 1,000, slide the decimal 1, 2, 3 places to the left. We need a placeholder. That 0 right there. So it is this. So, and we don't need this 0 really. It's just 0.08 liters. So what we're doing is we're taking this 90 students and multiplying by this part of a liter. Now, when we do that, it turns out to be, well, let's see. You see, again, there are a lot of ways to do this. We can go out to the side and do it. We can do it on a calculator. I can put it down right here as, let me do it right here. 0.08 times 90, and put the 0 down, and then 9 times 8 is 72. Write the 2 and carry the 7. 9 times 0 is 0, and 7 is 7. Oh, okay, I'm about done. Now I have 2 digits to the right of this decimal. I need 2 digits to the right of the decimal in the answer, so the decimal point goes here. So 7.2. 7.2 liters, then, is the amount of acid that's needed. But wait a second, we can only order by the whole liter. So if we're going to have enough acid for everybody, we need to order the next whole liter, so we need 8 liters of acid.